Welcome back. Let's bring our scene to life. Now it's time to move into animation. More specifically, we'll start working with keyframe animation, the core principle behind how animation works inside Blender. Keyframes are simply a way to tell Blender, at this exact moment in time, this object should be here. Then later, at another moment, it should move there. From those few instructions, Blender automatically calculates everything that happens in between. So instead of animating every single frame by hand, we only define the important moments, and Blender handles the motion that connects them. In this section, our goal is to create a cinematic camera movement, something intentional that really shows off our donuts in a clean, appealing, professional way. Here's the idea. We'll start with the camera positioned slightly above the donuts, entering from the left side of the scene. Then, very gradually, the camera moves downward and across to the right, almost like it's spiraling around the subject, before settling into a satisfying final reveal of the finished plated donuts. If you picture the motion, it's not a straight movement. Instead, the camera slowly wraps around the subject, letting the viewer discover the donuts rather than revealing everything all at once. This kind of camera animation is widely used in professional product cinematography. You'll see it all the time in food commercials, product advertisements, and cinematic product showcases. The motion gives the viewer time to appreciate the details. Alright, let's begin. First, switch to solid view. Then move your cursor down to the bottom of the screen. Click and drag the divider upward so we can reveal the timeline. If you scrub the timeline right now, you'll notice that nothing moves yet. That's completely normal. At this stage, we haven't told Blender to animate anything, so there's nothing to play. Before we animate the camera, it's important to make sure the camera itself is configured properly. Go ahead and select the camera. Then, in the Properties panel, switch to the camera settings. That's the green camera icon. The setting we want to check is the focal length. For a donut showcase like this, a focal length between 50 and 80 millimeters usually works very well. This range avoids wide-angle distortion where objects start stretching or bending. Instead, it produces a perspective that much closer to how we naturally see objects in real life. Alright, technically, we could animate the camera using simple location keyframes. You move the camera here, insert a keyframe. Move it there, insert another keyframe. And yes, that method works. But most of the time, that approach ends up looking a little mechanical. The camera ends up sliding through space instead of moving with intention. So instead, we'll use a much better and more cinematic technique, a pivot-based camera setup. This method allows the camera to move in smooth, controlled arcs while always staying focused on the subject. It's the same technique used in many professional product shots, especially in food cinematography and commercial work. Before setting this up, we need to decide one important thing. Where should the camera stay focused during the motion? In our case, that's very clear. The donuts are the hero of the shot, so our pivot point, the center of the camera movement, should sit roughly in the middle of the donuts. Hold Shift and right-click directly in the center of the donuts to place the 3D cursor there. Take a moment with this step. Precise placement really matters. Because everything will rotate around this point, now press Shift-A, add an empty, and choose the sphere type. Scale it down a bit. Just to clarify, this object won't appear in the final render. An empty is simply a helper object. It's visible in the viewport so we can work with it, but it never shows up in the final image. Think of it as an invisible control handle that we'll use to guide the camera. Next, we need to connect the camera to this empty. First, select the camera, then Shift-select the empty. Press Ctrl-P and choose Object, Keep Transform. This is the same parenting method we used earlier when attaching the icing to the donut. What this does is simple but extremely powerful. The camera keeps its current position, nothing jumps or snaps, but now its movement is controlled by the empty. Try rotating the empty for a moment. you'll see the camera smoothly orbit around the donuts while always staying focused on them. That's exactly the behavior we want. And this is why pivot-based animation works so well. Instead of the camera drifting randomly through 3D space, the motion becomes intentional, controlled, and much more cinematic. Alright, now we're ready to animate. The camera angle you're seeing right now will be our final hero shot. This is the moment where the donuts look their absolute best. So this position will become the end of our animation. You can choose any animation length you like, but for this scene, we'll use 120 frames. That gives the motion enough time to properly showcase the donuts. Before we begin, make sure the empty is selected, not the camera. That's important. All of our animation will happen through the empty, since it's driving the camera motion. Now move the playhead to frame 120. You can drag the playhead along the timeline, or simply type the frame number. Press N to open the Properties panel, then go to the Item tab. Here, we'll focus on the rotation values. Hover your cursor over the rotation fields, right-click, and choose Insert Keyframes. This records our final camera position, so now Blender knows, at frame 120, this is exactly how the camera should be. That's our ending keyframe. Next, move back to the first frame. You can drag the playhead all the way back or press Shift left arrow to jump directly to frame 1. At frame 1, we're going to define the starting camera angle. Rotate the empty along the X-axis so the camera starts higher and looks downward toward the donuts. That works nicely. Now rotate along the Z-axis. Turn it slowly while watching the edges of the frame. Make sure the camera doesn't clip through any objects. Before changing frames, we need to capture this starting position. Once again, right-click on the rotation values and choose Insert Keyframe. Now Blender knows exactly where the camera starts and where it ends. Press space to play the animation. You'll see the camera rotate smoothly from the upper left down toward the lower right, orbiting around the donuts. Technically, the animation works, but the motion still feels a bit linear, almost mechanical. This is where refinement really matters. In cinematic animation, camera movement rarely happens at a constant speed. Most of the time, the motion begins a little quicker and then gradually slows down as it approaches the final shot. That subtle slowdown, known as easing, it makes a huge difference in professional animation. To get better control over that motion, switch to the animation workspace at the top. This replaces the regular timeline with the dope sheet, giving us more precise control over how the animation behaves over time. Take a look at the rotation channels. For this animation, we only need rotation on the X and Z axes. The Y rotation isn't doing anything useful here, so select the Y rotation channel and delete it. Keeping only the channels we actually need helps keep the animation cleaner and much easier to manage while we refine the motion. Alright, now we're getting into the really fun part, polishing the motion. In the top left corner, change the editor type to the graph editor. Use the middle mouse button to pan around the graph, and press Home to frame all the curves so you can see the entire animation range. Start by selecting the X rotation curve. The graph editor is where the real animation control happens. It shows exactly how the animation values change over time, and this is where smooth cinematic motion is created. Right now, you'll probably notice something familiar. The motion starts slowly, speeds up through the middle, and then stops a little too abruptly at the end. We're going to refine that by reshaping the curve. Select the Start Keyframe handle. Press R to rotate it, and then slightly pull the handle inward, like that. This gives the beginning of the animation a little more momentum. Now move to the final keyframe. Press S and scale the handle outward slightly. That creates a smoother slowdown as the animation reaches the final shot, the easing we talked about earlier. Instead of the camera stopping suddenly, it gradually settles into the final reveal. Now select the Z rotation channel. Just like before, rotate the start handle slightly, then move to the final keyframe and scale its handle outward. Good. Now press space and play the animation. You'll notice the difference immediately. The camera starts a bit quicker, sweeps smoothly around the donuts, and then eases into the final hero shot. That's exactly the motion we're aiming for. Now, let's take the shot one step further. We can add another layer of movement by animating the camera distance using the scale of the pivot object. This technique is really useful. It allows the camera to start closer to the donuts and then slowly pull back as the animation progresses. That subtle pullback adds depth and gives the shot a stronger sense of three-dimensional space, almost like the camera is gliding through the scene. Move the playhead to the final keyframe. Hover over the scale values, right-click, and choose Insert Keyframes. Then move back to the first frame. Scale the empty slightly smaller so the camera starts a bit closer to the donuts. That looks good. Now right-click on the scale values again and insert another keyframe. If you look in the graph editor, you'll now see a new curve representing the scale animation. For a moment, hide the rotation curve so we can focus only on the scale. Just like we did earlier, select the final keyframe handles and scale them outward slightly. This creates a smooth pullback motion that complements the rotation we already animated. Select the Y scale channel. Scale its handles outward the same way. Good. Finally, repeat the same adjustment for the Z channel. Scale the handle outward in the same way so the motion stays consistent. Nice. Combined with the rotation we created earlier, the camera is now performing a controlled cinematic movement instead of a simple rotation. And that's exactly the kind of motion we want for a professional donut showcase. Take a moment to watch the animation play. Everything flows smoothly, arcs around the subject, and eases perfectly into the final shot. Just like we planned. While the animation is playing, look at the top left corner of the screen. You'll see FPS, which stands for frames per second. By default, Blender uses 24 frames per second, which is the traditional cinematic frame rate. For something slightly smoother and a bit more modern, we can increase this to 30 frames per second. Open the output settings. Find the frame rate drop-down under Format and set it to 30. You might also notice the animation continues past frame 120. That's because the end frame is still set to 250 by default. Simply change the end frame to 120. Now when you play the timeline, the animation runs exactly from start to finish. And that completes our animation phase. Smooth, controlled, and cinematic. Next, we'll move into cycles rendering. So go ahead and join me in the next part.